Hello. So this is experiment 520 that you're going to do for the first experiment, which is process measurement. This is the multi-tank discharge experiment. And as you can see, there's 3 tanks on the apparatus. They're all identical in terms of inside diameter and height. And what we're going to do is we're going to have water flowing into the top tank. Now, one nice thing about the upper tank, the tank number 1, is it has an overflow pipe on the back. So there's no way you can overflow that tank. The other tanks, however, do not have overflow, so you have to be very careful about that, not to overflow those tanks. And as you will see, it can be a little bit tricky getting these tanks at certain levels and keeping everything in control. So what is the kind of the main idea of this multi-tank discharge experiment? Well, level control pops up in chemical engineering all the time. And so you have to learn how to control levels of fluid inside tanks. Now these are relatively small tanks, but you get the idea that you could scale this up to a massive size. You could have multi-thousand or gallon tanks or whatever that you control the flows in and out of. And sometimes the tank level may change very slowly, sometimes it may change very quickly. And some of that information is going to be important for you to know. But one of the most important parts of this experiment is going to be the characterization of the input measurement sensor. So we have a differential pressure transducer. It's mounted at the bottom of each one of these tanks. And it's going to send the signal to the controller. Now that signal, the output signal from the sensor is the input signal to the controller. And this controller is set up to read, display units and counts. So it's not like an engineering unit like you'd be used to. And but the reason why we're doing it in these units is because the controller is going to make control decisions based on counts and not any kind of engineering units. Now we could scale this so it reads in some other engineering units like centimeters of water or whatever, but for now we're going to just leave it in counts. Now these controllers also have output. The output of the controller is the input to the final control element, which is going to be a control valve. Now, they call these proportionating valves, and I have removed the covers off the top of these valves so you can kind of see a little bit about the operation of the valve. And once I get the system started, you'll see how the valve kind of works. But when you go to do your experiment, when you come in for reconnoitering, I'm going to have the covers back on to protect the valves from damage. You'll also notice that on the bottom of each one of these tanks is a manual valve. Now these manual valves on the bottom of each tank can serve 2 purposes. One can be used for an emergency drain, so like if you're out of control on your system, you can't figure out how to get it back in control and your tank level is getting too high, you can open this valve and drain it into the main discharge tank, which is right here. And this main discharge tank actually sits on a scale as well and has a discharge valve that goes to a drain. So the purpose of that will be when you're actually measuring flow rates when you're at steady state. And so all you have to do is, just like on the Osborne Minerals demo, you can just close the discharge valve, watch the scale increase in mass. When it gets to a convenient point, you start timing. When it gets to another convenient point after a minute, 2 minutes, whatever, you stop timing, and then open the drain valve to let it go to the floor drain. But the other purpose of these valves can also be a disturbance variable. So now we're going to use this apparatus for all 3 experiments, but so for process measurement, process dynamics, and process control. So let me go ahead and start this thing up so you can see how it all works. First thing I want to do is check all my valves. It's always a smart idea. And I'm going to go ahead and open up that discharge valve. This one, that valve's open. And open up this one. Make sure my rotometer is closed. And it is. So now I'm going to pressurize the line. This is the main water supply here. This valve is leaking. They haven't fixed it yet. There's a little catch basin that then goes to the floor drain. That's why it's there. But shouldn't have any problems with any water getting on the floor. So I'm going to come back around. And I'm going to go ahead and introduce some water flow into the upper tank. And I'm going to set it pretty low to about 1.4 liters per minute. And I want to go ahead and put some water in this tank. I'm going to go ahead and slowly close this valve. Before I do that, Okay, so I've already turned on my power supply to provide power to these pumps. Let me turn this off for just a second. I'm going to turn this off and then I'm going to turn it back on again. So you can hear what happens when you turn on power to these control valves. What happens is that they go all the way to the closed position, and so you're going to hear them stall a little bit. That's a normal sound. So you can hear them. They're going to the completely closed position, and it'll stop. The noise will stop in just a few minutes. And what I'll also do is I'm going to go ahead and turn on my power supplies. Now before you turn on these power supplies, it's important to make sure that they're configured properly. You'll see that there's a current setting and a voltage setting. The current setting is going to be all the way to maximum, and the voltage setting is going to be all the way to minimum. You also have multimeters, which you can't see on the video, but that's okay. When you come in for reconnoitering, you'll be able to look at them and see the display. And go ahead and power these on. Now, I'm going to start putting my water back in the tank now. And before you send a signal to the control valve to open up, you want to have some water in the tank about halfway. So I might increase the water flow just a bit to get some water in there. And again, the nice thing about this upper tank is you cannot overflow it with this, well, I won't say you can't. It's very difficult to overflow. I hope that it's impossible, but we'll see. Okay, now I'm going to dial it back down. I'm going to go ahead and open up my control valve. And as you can see, the valve's now starting to open. And we have some flow now going into the second tank. So here's the interesting bit. So for level control, you have to have a set point level, okay? Some set point that you want to control, keep the tank at that specific level. That's called the set point. So right now, we're at 1253 counts, 1252, so it's dropping a little bit. So what does that mean? That means that the outlet flow is a little bit higher than the inlet flow, and that's why it's dropping. So if I reduce the signal to the control valve, in other words, put less power to it, the valve will shut a little bit. And now we're going in the opposite direction. It's kind of oscillating around a little bit. Now it's starting to go up a little bit. So what that means is with this rising, the set point level, or this measurement level rising, that means that the inlet flow is higher than the outlet flow. And so we get an accumulation of water inside the tank. Now, this is all very important to understand because in order for the controller to make control decisions, it looks at the error, which is the difference between the set point value and the measured value. Okay? So it's not just increase or decrease, but it's the actual difference between the two. That's called the error, and that's what the controller makes decisions on. And so in order for you to be able to program this controller so that it knows what to do when the level's too high or too low, you have to you have to characterize your final control element, which is what we're going to do on this experiment. So of course this final control element is going to be this control valve. And so you're going to look at how much power you have to send to the valve in order to overcome the inlet flow. So right now, inlet flow is at 1.4 liters per minute. And so my valve is not giving me quite 1.4. And if I increase the power to it, maybe a little bit more. Oh, that's not bad. It's actually pretty well out there. It goes. So it may take a minute, a little bit of a delay, or there may be some oscillations in there. So that's pretty good. So let's say that we wanted 1300 as our set point level. Now, one thing that we have to know is, what is our control range for our valve? Because we may be able to get more flow through the valve if, say, the level of water in the tank is higher than when it's lower. And so that's kind of the range of control. And so we want to look at the different ranges of control that we have for our valve. And so that's something you're going to explore in the first lab. And so not only are you going to characterize the valve 1 for tank 1, but you're also, once you characterize that one first, then you're going to characterize valve 2, and you're going to compare the two. So that'll be one thing that's important for your report. So, and I may not have mentioned this initially. I know I talked about the differential pressure sensor. But what you're going to want to know is what is the relationship between the level of water in the tank and the output of the sensor. Okay? So, as you can see, it makes sense that the output is higher when the water level is higher. And as the water level drops, the sensor output also drops. And the question is it going to be the same? The sensor performance, is it going to be the same for tank 1 as it is for tank 2? Well, that's something that you're going to find out. Same thing as the performance of the valve, the control valve. Does control valve number 2 function the same way control valve number 1 does? Or is there some differences between those valves? So those are some of the things you're going to explore on the process measurements. And I'm sure you'll have plenty of questions. So when you come in for record ordering, we can talk about those questions and get them clarified for you. Thank you very much.